All right, so very, very warm welcome to all of you once again. Very good morning and welcome to today's webinar, which is on explainable artificial intelligence AI for financial models. And this is, as you all probably by now know, this is part of our regular webinar series deep dive with IIQF experts. Today's webinar would be presented by Mr. Sanjay Bhatia. Sanjay, once again, thanks for joining. Right. So, I mean, before we proceed with the webinar, just to give a very brief introduction of Sanjay. Sanjay has done his MBA in finance and has done his MSc in machine learning and AI from Liverpool John Moores University, and he also has a postgraduate diploma in machine learning and AI from IIT Bangalore. Is currently working as a director for UBS in the risk modeling and analytics team, so where he does model risk management and control in the chief risk office function. Sanjay has been a risk management and analytics professional with more than 15 years of mainstay experience in risk models, methodology space encompassing BSL, advanced AIRB, IFRS 9, IMM and SSER exposure, XBA, FRTB, OTC derivative pricing and other advanced modeling topics. He has previously worked with various foreign banks, Barclays, RBS, Citi, Credit Suisse, mostly in the risk consulting domain. And he's very passionate about imparting practical model understanding and insights, and has been a professional trainer for corporate and investment banks. He is also one of our lead faculty. He is the lead faculty of our machine learning and data science related courses as well. His areas of interest are credit and counterparty credit risk, market risk, stress testing, stochastic modeling, quantitative finance, and machine learning. Right. So before I hand over the session to Sanjay, a very brief lay down on how we would be going about in the session. Right. So as you all know, this would be like about 1.5 hours. 1 hour, Sanjay would be speaking on the topic, and then post that we would take up the Q&A. I mean, we'll have the Q&A where we'll take up all the questions, queries that you will have. So, I mean, unfortunately, since the participation is quite large, so I would not be able to allow everybody to speak. But nonetheless, we want the webinar to be very interactive. So please feel free to type in your questions or queries in the chat window, and I mean, we would definitely moderate and take up all those Q&A. I mean, all those questions during our Q&A session, right? So with that, I'll hand over the session to Sanjay and to start the session, and then of course, well, once you're ready, Sanjay, you can start. I'm making you the presenter.
Okay. Yeah. Thanks, Nitish. Hope my deck is viewable.
Yes, we can view your deck.
Okay. So first, at the outset, a very warm welcome to everyone on a maybe not so warm, right, monsoon season, but good that you're warming up for such informative sessions. And today, our focus lens would be on a topic which has captured the pulse of many researchers in AI, data science, and machine learning, specifically in advanced AI ML models. And when we talk about advanced AI models, very particularly the deep learning models, which are touted to be and sometimes blamed for their misinterpretability or lack of interpretability and lack of intuition. And generally these models are considered to be a bit black box, and that's why a new stream has emerged in the backdrop, which we call the explainable AI, right? And which focuses on explaining the output of these models, focuses on how these models should be interpreted, focuses also on how various contributors within the model, like various variables, could be attributed to the output level. So a lot of these amalgamation of things we are going to touch upon today, and specifically we would be talking about the cutting edge techniques which are getting explored more to make the models more interpretable, intuitive and explainable and transparent, right? So we would be going there, but just maybe from a definitional perspective, how personally I see this uh, explainable AI, which is generally termed as XAI, right? It focuses on uh, model explainability to make models fair, to make models accountable, to make models transparent. What we call generally nowadays, there's a new term which is coined in the market, which is called FAT, right? So we want our AI, futuristic AI models pipeline to be constituting models which are fat. Fat means they are complying with regulatory requirements on fairness, and they are complying with regulatory requirements on accountability of the decisions, automated decisions taken by these models. They are also need to be compliant with the transparency and traceability, and we will be talking there. But before we go there, let's see maybe on this nice pictorial representation how different AI ML models versus the conventional some of the statistical models or mathematical models fare in terms of their accuracy versus interpretability. As you may see, there's no doubt that there's a trade-off or balancing act between the model accuracy on one side and model interpretability on another side. uh, what it means is that as you focus more and more on making the model more accurate and precise, and uh, to produce the point forecast, right? They tend to make the model more complex, right? By focusing too much on the accuracy and the model precision, you tend to make model too complex, and the model complexity grows. And as the model complexity grows, its interpretability take a hit. So the hit which is taken by interpretability with the advent of many AI/ML models which are much more precise than statistical techniques or statistical models is exactly what we are talking about. And there's no doubt that such accuracy has made some compromises on model explainability, model intuition, model interpretability, model analytical traceability, model transparency, the trust in the models, maybe the accountability of the models, because the decisions the models are taking, right, they are completely automated when it comes to AI ML models. So you could see the major culprits of maybe lacking model interpretability are deep learning algorithms, all different type of neural networks, uh, mm, including maybe recurrent neural network, artificial neural network, multi-layer perceptrons, and various other types of adaptation of those neural networks, like long short-term memory, which is used for time series forecasting, uh, gated recurrent unit, and generative AI, right? So all of this generative AI, deep learning, and the neural networks are the major culprits why the whole regulatory landscape is changing, and trying to maybe not accept these models with a pinch of salt, and asking for more to be delivered to make them more transparent, responsible, accountable, fair, and non-discriminatory, right? Then is the second slot which is occupied on this you know curve, maybe is ensemble learning, some of the hybrid models, right? Like random forest, which are created out of multiple decision trees, right? So they while the constituents of such hybrid models, which is essentially the decision tree or classification and regression tree, are very very interpretable, and Many users of the model were very comfortable with decision trees and car trees, maybe classification and regression trees, but the way they have been combined, and not to limited extent, but largely creating a dense forest under the random forest ensemble methods, and the way in some other algorithms like the boosting, the way one tree is built on top of another tree, and then they're sequentially building multiple trees, the output and its traceability, what the model is trying to predict, and its traceability to the drivers of the model has been lost, right? So that is where maybe ensemble sits. Support vector machine, there's no guess. I would not say that support vector machine is a real culprit, because essentially many classification algorithm, like you heard of logistic regression or other statistical methods of doing classification problem, support vector machine is in itself designed to do the non-linear problems. Like many a times we have a blame on these statistical models that they simply assume the relationship to be very linear, right? But support vector machines use some complex functions like radial basis functions to make them to uh, capture the non-linearity in data, to capture the non-linearity in relationship, and that's why uh, to an extent we could say that support vector machine is inherently a bit uh, mm, uninterpretable, right? Inherently a bit uninterpretable, because it is in itself doing a very complex thing of uh, you know uh, modeling the non-linearities and modeling the non-linear relationship. So but it still sits alongside these deep learning neural networks and the hybrid ensemble methods, right? As taking the blame for the lack of explainability out here, right? Bayesian models, uh, those who know the Bayes theorem and are fan of the Bayes theorem as much as much as I am, right? Many statisticians are, right? So the Bayes theorem and the Bayes formula is used behind these models, but generally the market, many layman users of the models generally understand the frequentist way, or the of calculating the probability, not the Bayes formula very well and its application very well. So it need some rework to explain the Bayesian based models more to the users of the models. Then there are generalized additive models, which are an extension of how we create linear models. Then there are the other four are very much considered to be still to a great extent very interpretable, like your clustering algorithm, where we do k nearest neighbor, knn clustering. The decision tree, as I told, that on a standalone merit decision tree is very interpretable, right? But when it comes to combining multiple trees under the ensemble method, like bagging and boosting kind of techniques, and creating a random forest or a boosting algorithm, they become somehow very less interpretable in that sense. And obviously linear logistic regression and rule based learning scores very high in terms of the model interpretability. Now the challenge is twofold, right? You got to seek the your modeling the stakeholders blessings and the regulator blessings for getting your model approved, right? uh, and when you go back to them and when you try to present the results, they sometimes completely, it's completely black box to them, and they sometimes say that make a model a glass box, not a black box. Make a model something which is transparent to us, right? How it functions, what is the internal methodology mechanism, what are the components of the model, how each of the variable is playing a role in creating the output and contributing to the output, do some attributions, right? They always are more focused on understanding, interpreting, having the comprehensibility and interpretability and the intuition behind the model, because they are going to take decisions on that, and some of the key decisions, like whether I should set my limit at what level, what the model is telling, what should be the risk limits are, how would I justify those risk limit to my counterparty, right? How would I justify my credit underwriting decision, whether to give a loan or not to give a loan to somebody, right? Whether my model is not with some inherent bias that it is lending to someone and excluding someone intentionally, that might lead to some kind of a legal or reputational risk, or some kind of a legal suit. Somebody could sue me for that. So they have a variety of different application, uh, application focus, maybe where they want the model to be well explainable, not only to them, but to their regulators, to their auditors, to the model governance forum, to anyone who can come and audit the model, right? Who can come and validate the model, to model validators. So this is a key topic for model validators, model regulators, model auditors, uh, even those actual counterparties with whom we are doing very uh, you know high value of business, high value of business, like maybe specifically in derivative trading. You have to explain why you are quoting a particular price to a particular counterparty, right? What is the maybe mechanics of that particular price, how you arrived at that particular price. You got to explain your valuation of various products, or various instruments on your sitting on your balance sheet, to various auditors, right? So there the explainability focus and interpretability focus is of paramount importance, and that's where, right, it is no doubt that this topic in itself is going to be both a bottleneck as well as an enabler for the adoption of AI/ML model in a wide span way, right? If tomorrow in next 10 years we are going to see most of these statistical models or mathematical models or assumption theory based models or rule based models being replaced by this huge wave of AI ML models, which are purely data driven models, then this need to be first of all fixed. And that's why a lot of research focus, a lot of focus of many consulting firms, many product companies, many fintech firms is on this topic called AI, explainable AI, right? How to explain the AI, right, to someone who is going to get affected by the decision taken by AI. And most of these decisions are taken very automated fashion, like maybe when it comes to uh, automated portfolio manager, or maybe high frequency trading, or maybe even some of the risk management, how, like hedging, dynamic hedging done by these models, all by themselves, with very low touch point or manual touch points. We need to be pretty sure, that we trust these models, these models are reliable, these models are bankable, and our stakeholders trust these models. We need to just make that thing very quantitatively established, right? So what are the pitfalls of AI? We talk about maybe that AI is maybe going to be the next redefining theme for how the financial world or financial sector or BFSI industry operates, right? With many challenger banks propping up, right? In terms of the fintech companies and peer-to-peer lending firms, right? We do not see day far when most of these challenger banks will become the mainstream banks, and the mainstream banks who have been very uh, you know big elephants, they can't dance anymore, and they would succumb to these very nimble firms who have created their business model around AI/ML products. Now, but the pitfalls of AI are that many of the models or algorithms or machines which are created. They are very data hungry monsters. They need continuously more and more data, right, to calibrate themselves, to reparameterize themselves, to reformulate themselves, to calibrate themselves, to auto learn, right, to auto adapt, to dynamically change themselves in changing markets. That's the promise which they do. But on the other side, obviously, the data is the key. They need terabytes or petabytes of data, or maybe a large volume of big data, right, to train them and to maintain them, and to keep making sure that they perform the way they are expected to perform, right. You need continuous data to be uh, throughput through them, so that they would keep learning, right. They would keep detecting patterns, they would keep identifying relationships, they would keep reparameterizing themselves, reformulating themselves, recalibrating themselves, and maybe also in a way dynamically adjust themselves according to the data, because that's where the promise is, and that's where the initial proposition why they uh, replace the mainstream statistical models. So they are data hungry machines. The other part is that when somebody is so much tied to the data, right, so much, the learning of the model or algorithm is so much tied to the data, they have certain tendency called overlearning and overfitting, right. It means that they not only learn the patterns from the data, they learn many of the other things which are not warranted for, like noise in the data, right, some of the randomness in the data, right. So they tend to overfit the data, right, because they are purely creating the model out of the data, right, and not following any assumptions or theories or any broader market principle, the how the market functions, or how the maybe certain derivative functions or certain distribution functions in the market. They are not making any of the assumption, they are theory free, they are assumption free, so that m- uh, make them more rely on data, right, and pick up all those you know things which are required for modeling. What is the underlying distribution, what are the parameters of that particular distribution, right, what are basically the key variables, all of that particular thing directly from data rather than from theory or some kind of a literature. They don't rely on those kind of, or some kind of assumption. No, they, or hypothesis. That's the thing for the statistical models, not for the AIML models, right. So in doing so, the way of their learning is so that they become very data sticky, and they become they capture the noise in the data. They sometimes mug up and memorize the data points itself, right. And when somebody mug up and memorize the data points, it becomes even far more sensitive to the data. The other part is they have a bias, they have multiple bias in them, and sometimes they face two kind of pitfalls, like getting into the bias trap, getting into the data leakage trap, right. So they become sometimes biased. There are different kind of biases, and generally regulator, specifically EBA, has pointed this out. European Banking Authority has pointed this out, that with all kind of biases built into the model, how can we be sure that model is going to not discriminate, right, while taking decision, right. So they are investigating, like whether the model, like many of the credit scoring models in Europe, they are discriminating against LGBT communities, they are discriminating against those people who are maybe uh, uh, who belong to the startup culture, or these coming from the start employed or part of the startup firms, right. Do they have such biases, right? And such biases should not be there, right. Because the problem here is that because the model is not guided into its learning, it's learning from the data, it's learning from the historical data, it's learning from the new data. So whatever decisions and whatever themes or patterns have already been there, the model is learning from that. And sometimes we have data which is discriminative data, like many firms, if they have used such data where the credit decision has been in favor of some counterparties and not in favor of some other counterparties, right? The model will learn that, so that will make them have some bias, right? That will make them have some, and then there are data leakages as well, right? Where certain leakage of data could create the GDPR issues, could create the privacy issues, data privacy issues, right? Because the model is getting to learn everything about the counterparty, about the customer, even those things which are confidential about the customer, right? And sometimes, you cannot control model in order to carry that forward in its output, right? Sometimes if by looking at the output as a model user you could make it out, oh, the person is belong to LGBT community, or the person is that's why this decision has been given by the algorithm, or the person belongs to the startup culture, that's why this decision has been dispensed by the algorithm. That will be a big issue, which is again one particular thrust in the Europe, that there's a strong data privacy regulation which is coming through, called GDPR regulation, which will be imposing quite a constraint on these models, in the way they use the data, in the way they manipulate the data, in the way they transform the data, in the way they use that particular data for model explanations. And the last but not the least, which is maybe also the focus of this, explainability and performance attribution. And without any doubts, now we are pretty much settled with the this assertion of ours that explainability is one of the cornerstone, it is one of the cornerstone of model adoption, AIML adoption, right? As well as performance attribution will make these models more, will make others trust these models, rely on these models more comfortably, right? So all these things coming together, now let's maybe go into the main, what are the various techniques. Let me maybe, yeah. So there are different techniques which are explored in the exploration stage as of now to explain the model output. And uh, but we should first of all understand what these techniques can be, how these techniques can be categorized, classified, and maybe bucketed, right? The first approach is doing a local analysis, right? Local explanation, right? Local explainability. Local explainability is the main focus, where the what do we mean by local versus global explainability? Now there are two terms coined here: the global explainability versus the local explainability. The local explainability is simply this, that I'm going to look at every decision taken by the model, like whom they have given credit, whom they have declined credit, or maybe rejected the loan application, where they have accepted the loan application, where they have rejected the loan application. And we are going to go at the observation level, right, to explain, right, why that decision has been taken by the model, right? So that is uh, 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 how why the model is behaving such, and is there a consistency in model taking this decision consistently, or is it something that, for a strata of observation, or for a given subset of observation, the model is taking a bit of discriminatory decisions, and for the others the model is generally fine, right? It is taking appropriate decisions, right? So that is uh, 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 to check the model plausibility. Plausibility means that whether the model is rightly taking the decision, taking the plausible decision, taking the real life decision, and those kind of decision which can be well acceptable by all, right? So plausibility checking at the observation level, which is a very local effect, that what decision the model has taken and what contributed to that particular decision. Can the model explain? So there's a technique here, right? There's a technique here. Let me maybe put down this. Yeah, there's a technique here called LIME, right? Local interpretable model agnostic applications, right? That is the first technique which is now being applied, and many researchers are trying to explore these techniques, how to make the AIML models more locally interpretable. Model agnostic here means that irrespective of the overall model, we are going to focus on the local explanation and local interpretability, right? Then there is a related thing called partial dependence plots, which tells you which particular variable, right, was dependent, was uh, you know uh, uh, driving that particular decision, or decision was dependent upon which particular variable. What were the partial contribution of each variable, right, in the model in making that particular decision. So this is at an individual standalone decision level, uh, at an individual observation level, uh, even further decomposing that what a variable contribute to that particular decision, right? So these are techniques which focuses on that. uh, then maybe there's a model level or global level explanation, right? So the first one were maybe local level explanation. Now the global level explanation, right? uh, the global level explanation explain the model and its design and its methodology for the entire model, not for a data set, right? So there we are not examining individual observation, but we are examining the whole data set and how the model has performed on the entire data set rather than the individual observation, right? So there's a technique called Shapley additive explanation, Shapley additive explanation, which is based on game theory, right? So this this is a decision theory or game theory, it could be used to explain the model itself. Now this kind of thing is required for when you are explaining the model to regulators to seek their approval, right? When you have submitted your AIML model to regulators to seek the approval. So this kind of a, right, global level explanation is more of interest for regulators, for your auditors, for your model validation forums, for your model governance forum, where you are explaining the model, right? What this model is doing, what are the mechanics of the model, what is the methodology of the model, right? What are each particular variable, how much importance each particular variable, what is the significance of each particular variable that it carries within the model, right? So that is how it the model in internally you know uh, interact with the inputs, intermediate outputs, and the final outputs, creating the model traceability, where we could trace back the final output to the inputs and what kind of importance each input carry in producing the final output, not just local effect but the global effect. So we are going to focus on the global thing, the entire data set which has been used to uh, estimate the model, right? So the third thing is the surrogate model development, right? uh, Now this thing is uh, for external stakeholders, right? What generally we are doing is we are creating some of the very complex models. uh, we are explaining some of the very complex and opaque models, non-transparent models, by comparing them with a explainable model. So it is a surrogate concept where for every complex model or opaque model, right, we are creating another benchmark model which is more explainable. So it requires quite an effort, but uh, so be it. If you want maybe to further advance your adoption of AIML and complex algorithms, you got to you choose this approach where you could do another model, build another model which is focused on explaining the main champion model, right? So that kind of a surrogate model development is all about explaining the complex and a very intricate and very opaque model. And what do we mean by that? Those model which does a very high dimensional problem solving, like there are so many features, so many variables in those models. They focus on doing prediction for based on non-linear relationship. So they capture non-linearity, they capture high dimensionality. These model capture high correlation between variables. So these are complex models, right? And they are not limited to just few variables, right? Many of the climate and sustainability risk models, if you see, they examine hundreds of variables. What is the sea level, how the sea level is rising, what is the maybe flood line level, what is the river flooding level, what is the right maybe what is the precipitation level, right? What is the rising temperature, maybe across continents, right? Right. What is the rate at which deforestation is happening, right? Many of the data from geo satellite network, maybe lower orbiting geo satellite signals, they are in real time they're processing, they're examining this data, and what's its effect on the actual assets value, right? In red zones, in maybe amber zones, in green zones. So the model complexity is bound to go multifold, because there's a high dimensional problem, and with a very large set of variables, and the interrelationship or interactions between those variables is non-linear, right? And there are non-linearities involved, there's multicollinearity involved. Many of the variables which you include in your model, they co-vary together, they have a strong correlation, right? But you have to include both in the model, right? So some of these require us to create some another model which could act as a model which could create insights into this complex model, right? So we have some cross batch memory, or generalized additive models, or short decision trees, or linear models which we could build around these models, which could explain. The focus of those models wouldn't be nothing, like they would not be real decision making models, but they would be models who would be explaining the output of this particular main champion model. The last is the contrastive analysis, right? You could use multiple scenarios, right? What if scenarios, and you could change maybe certain values in the model, right? And you could examine the give those scenarios to the model and see, right, how the model behaves, right? What happen when certain modifications or amendments are done to the model, or certain things are removed or added to the model, right? You could create those kind of scenarios to explain, like if a particular variable or a factor is removed, or a new variable or a factor is added, what is the marginal contribution, how much the accuracy or AUC of the model is increasing, right? So that is what we can examine. So that is contrastive analysis, right? And we can convey this particular results of such what if scenarios to our regulators, to as a counterfactual way, right? That okay, we can we have understood the model, we have done the model sensitivity testing, or through certain scenarios we have tried to play around with different coefficients of the model, parameters of the model, hyperparameters of the model, variable specification of the model, changing the slight formulation of the model. And then this is maybe from a contrasting view, we could understand that model is uh, you know behaving in this way, right? So you could do that as well. So these are the different ways, approaches, which are part of research, part of maybe consultative interests, where the model have been interrogated, AI model have been interrogated and experimented with, to finally see how better we could explain them. You could adopt multiple approaches at the same time. That depends upon the uh, uh, the uh, the quantum of the task at hand, right? Is it a real very complex intricate model which you are tackling or is it moderate complexity? If it is moderate complexity, you could adopt a local explanation. Whether that model is majorly used for decisioning with respect to counterparty or customer, like business decision, or is it a regulatory model? If it is mainly for business decision, local explainability will help more. If it is majorly a regulatory model, the global explainability will help more. If it is a both, then you have no choice. You have to both explain the global, you have to do the global explanation as well as the local explanation, the explanation of local effects as well as the global effects within the model, right? Now, coming to explainability is a term, and generally there's a tendency in the market and among practitioners to coin the term and then leave it there, right? So, and that is mostly the case typically with consultative firms, they like McKinsey or BCG. I don't blame them, but they earn their big checks, they paychecks from that, right? They coin the term and then leave there. The point is that, you know, who is going to explain first of all what it means? What do you mean by explainability? So as far as I see it, trawling through multiple research papers, I see it in four ways. First is the trustworthiness of the model, whether you trust this different decisions made by the model, and trust the model itself and its individual predictions, right? So it captures your maybe uh, comfort with both global effects, when you are globally comfortable with the model, right, as an acceptable model, as well as local effects, so how the model is taking real life decision, right? So that's around the trustworthiness, how you promote trustworthiness in these kind of models which are so far touted as black box, how you can make them glass box, right? The second part is the transparency. Obviously you have created a model, right? Somebody really said that all models are incorrect, but many of them are useful right? Right, so all models have their own pitfalls, their own shortcomings, their own weaknesses, their own limitations, their own constraints, right? But most of them are useful. That's the era or world we are living in. We most of the decisions are taken on these models, like your var or expected shortfall is used for limit setting, for loss estimation, right? Your PD LGD EAD models are used for credit decision making, right? Your margin models are used for, in derivative trade to make a margin call. All models, they might be having some part which might be incorrect, right, which might not be completely a most perfect or precise or accurate decision, right? But they are useful, they are useful. You cannot expect a human to take such decision at such ferocious pace, and specifically in this age of big data, when data is coming in real time with high velocity, variety, variation, you know and different forms of data is coming. You need some algorithm to gobble it up and keep giving me real time decision or real time analytics, right? So but transparency is all about somebody clearly noting down in the model doc or in the model governance doc that what are the strengths and weaknesses of the model, what are the shortcomings of the model, what are the assumptions and limitations of the models. This thing is a must for you to seek any acceptability, specifically in regulatory eyes, for that particular model. The third thing is the model traceability. uh, and I will say that this is a bit different than only knowing the global effects and the local effects, but it is that, okay, I know that model has taken this decision and I can explain that, but can I explain that in terms of the inputs of the model? Can I further decompose that, which variable, like leverage ratio or liquidity ratio or efficiency ratio or profitability ratio or cash ratio or cash flows ratios, how much they contributed to the, the rating assigned to a particular, the credit rating assigned to a particular firm, right? So that's called traceability, right? Guiding principle here is that to clearly maybe put forth uh, how the model is analytically traceable, whether the output produced by the model can be decomposed by the constituents which are part of the model, by the variable set or variables, different factors which are part of the model, right? So this again enhances the decision making, because if you were to based on certain regulation, right, ethical, there's a stream called ethical AI, right? There are certain hard binded regulation which are coming through, which are in draft mode by various regulators. And uh, the idea there is that while taking a rejection decision or decline decision, right, for loan application or for a trade, if you have declined a trade with a counterparty, you got to explain, right, that what was wrong with that particular counterparty. Not just say very superficially, oh, you were not a good rated counterparty, or your credit score was not up to the mark, up to my uh, was below my tolerance level, that's why I took a decision to decline your application. No, you got to explain a bit further, right, than that, what was wrong, which aspect of that particular counterparty, which risk factor of that particular counterparty was significant, so that you could, it was beyond your tolerance threshold, right? So that requires some traceability within the model. And last but not the least, model interpretability. Interpretability means this, that look at a decision tree, a flow chart kind of a tree, where maybe somebody, your CRO or CFO or CTO, or CEO come morning, in the morning dashboard, and if you want to understand why this has happened, right, why there's a blub, right, which is popping up on their dashboards, right, they could further go and they could see it in clear fashion, that okay, uh, and they would be able to interpret it, right, for their decision making. So this interpretability is mostly, right, for those people who are taking decisions, who are the internal stakeholders, who are the decision makers for the bank, right. They should know what are the sources of errors, what are the sources of biases, what are the sources of prejudices within the model, which the model is susceptible or vulnerable to, right. So they, then only they would be able to take their decision, they would be able to exercise their judgment, right, right, to what extent they want to tweak the model output, whether they want to override it, they want to overlay it, what they want to do, right, or they should accept the model output, right, with some caution, right. So because their neck is on line, right. The If tomorrow somebody is going to file a legal suit, or uh, some regulatory fine or seizures will happen, they are going to be responsible, right. So making comfortable your stakeholders, right, and making the model interpretable for them is also of equal importance than doing it for the outside, the external stakeholders. The internal stakeholders are also very important. So as I explained this, there are two ways going about it. Do some local explanation, which we are calling locally interpretable model explanative model agnostic explanation, lime, locally interpretable model agnostic explanation. And the second one is the based on the game theory and some of the decision theory. This and other way of global explanation is uh, and which the Shapley additive explanation, which also do the local explanation, but not as good as lime sometimes, right. So there's a sense of in some cases the local version of Shapley would explain, in a as good as lime, but in some other cases not. But then maybe the major point is this Shapley technique could be used both for local explanation and global explanation. Yeah, I'll show you maybe a few examples of that as well. But let's understand this Shapley. So Shapley is based on some kind of a um, game theory. And generally, if you have read a book or a piece of paper on game theory, right, or decision theory, right, it's a correlation and cooperative game, right, where maybe every player is a stochastic variable. It has to contribute something to the outcome of the game, like winning the game, right. And they play in correlation, like they do not compete, the variables do not compete with each other, right? The players do not compete with each other, they are part of the same team, they have same objective, same purpose, right? And what it does is, based on some mathematics, it uh, captures the marginal average marginal contribution of different ordering of variables. Different ordering of variables means alternative, different variable specifications. Like if I take 10 variables, a set of 10 variables, and then take a set of different 10 variables, take a set of different 10 variables, right? Different ordering of that variables, right? And what is the marginal contribution of each of these variables, and they're sitting in different ordering to the output of the model, right? So it by doing so, it's just like you have extra players and you are changing your team formation, right? You are changing your team formation, and every time you are seeing, right, what was the chances of maybe winning, right? Every time you changes your team, right? You have quite a permutation and combination to try, and it tracks the relative importance of each variable. Now, the point to note here, very important point, why we are trying to assess the relative importance of a particular variable, right? Uh, in contributing to the final output. But why we are doing it in orderings? In orderings because it matters, because if the certain leverage ratio, like debt to equity or debt to capital, is part of one particular 10 other set of variables, right? Right, it matters if that order change, right, and another one variable is replaced with another, whether that variable, debt to equity or debt to capital, is contributing the same way, right? So that's what we are trying to note here. So it is based on some mathematical thing, right? But that is a thing for the actual lecture. But just to give you a flavor, right, what it says is that a variable which is not contributing to a subset of features must receive zero contribution, obviously, right? uh, every time some variable are contributing, right, and at it would lead to some non-zero attribution, and that lead to some total gain, right? And that would add to the model efficiency. Some of the variables which are symmetrical should get equal contribution, and linearity means that the sum of games, right, the weighted sum of games is equal to the uh, 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 you know sum of the attributions for each game, right? So maybe so this is a linearity, that if I add up the games which are played by different setting, different teams, right, different formations, right, if I add up their total winnings or total efficiency or total gain, right, that should be a combination of if I add the individual players winning, right? So that's maybe where it is. And we have quite a lot of different plots, like waterfall plots to explain, or some fancy b swan plots to explain maybe uh, the individual predictions, and what they are contributing, how the variables are contributing to each of the decisions. But uh, right, let me maybe show you one of the output from the model. So this is a waterfall plot. You could see that, right, there are multiple variables, right? We are trying to predict something with these variables, and these variables have contributed to certain extent, right? Now this particular waterfall plot is showing me that what was the base value, right, and what was the contribution made uh, by for a particular, like for a particular decision, what was the base value, right? And what were the, like, this is a housing price prediction problem, where you could see that on these are all variables, like number of rooms, right? Percentage of working class maybe living in that particular area, right? Percentage of houses in and around that particular area which are built, older houses built before 1940, remoteness, and all these, right? Interconnectedness, crime rate, industrial zone, right? uh, pupil to teacher ratio, right? Like the education, uh, infrastructure in that area, residential zone in that area, whether it's around river or not, right? So you could maybe break it down using some waterfall plot, and it would explain what the final prediction in terms of its base values, what was the base value, and what was base value means the average value, and what was the over and above that each of the variables is explaining. Yeah, so you could do that using this. Maybe this is just a sample, so these are some of the other ways of looking at it, right? That what each variable contributed, right, to the mean value. So beyond the mean value, right, what is the contribution of my percentage working class? Like if percentage working class is higher in a particular area, the prices of that particular area, housing prices of that particular area is higher. So this particular variable has contributed to a very great extent beyond the average effect of the explaining the model, right? So this is very key variable. Number of rooms is very key variable. I don't know what NOx concentration is, but maybe I don't remember on top of my head, but this is a key variable. Remoteness is key variable. Crime rate is key variable. Uh, the locality and how old it is by the houses, how old the houses are. This is a key variable. Tax rate is a key variable. Pupil to teacher, in the order, right? Pupil to teacher ratio is a key variable, and then rest is whether there is an industrial zone, residential zone, whether it's around the river, or what is the connectedness, doesn't seem to be very key variable in contributing, right? So we have explained maybe such effects, and you could see this is called the B swan plot. So B swan plot for every single variable, for every single observation, right? Point is drawn like this, right? And it the SHAP values are on by which we mean that what is the overall impact of that particular variable on the model output is on x-axis, right? And all the variables are on y-axis, and you could clearly see maybe there's we could use this kind of a plot to create an output for our regulators, for our maybe decision makers, internal stakeholders, as well as for somebody for whom we are taking decision, like customers, or maybe for somebody like front office who is going to explain that output to the counterparty, right? So that's maybe where it I think it provides a good summary of maybe a good thorough overview of the entire thing. But I'm happy to take on questions and maybe lead us to more interaction on this topic. Yeah, over to you. Yeah, yeah. Thanks.
Yeah, yeah, you're saying something.
No, that's it. Maybe from a coverage perspective, I'm done. Happy to maybe take questions on this topic, because this is quite a novel interest, topic of novel interest. Let's see
Yeah.
how people read through it, right?
Yeah, sure. So we would be taking up questions, but before that, maybe just to give you a little bit of breather and also to maybe introduce ourselves a little bit and the work that we have been doing. So we would be like, again, maybe like in a quick 2-minute summary of the work that we're doing, and then we'll take up the questions. There are a lot of questions that I can see. All right. So before we go into the Q&A, allow us to just quickly introduce ourselves and, like, again, maybe help you with like the resources that actually you can use to make a wonderful career in this field of machine learning, data science, and related areas of finance, or like people who are interested in the general field of quant finance, financial engineering, or risk management. I mean, help is there to make a wonderful career through us, right? So, I mean, as you all probably might know, but just very quickly, Indian Institute of Quantitative Finance, the body which I represent, is an education and training body concentrating and been, or rather pioneering education in the field of quant finance, financial engineering, risk management, and quantitative algorithmic trading and AI and ML applications, right? We were founded by pioneers in India and top experts from the field of financial risk management, financial engineering, and investment banking. And our endeavor always has been to bring in cutting edge technologies that are used in finance, and then bring into our courses, so it prepares you for roles in this kind of industries, right? For those who are enthusiastic about building a career or maybe understanding about the applications of artificial intelligence, machine learning, and data science in finance, so we have various courses, which you can utilize to learn and then build a career, right? So we have a course called Artificial Intelligence for Finance, which is a very comprehensive, about 9 months program, conducted on the weekends. These are all weekend instructor-led programs, right? So the AI for Finance is 9 months, and the AI for Finance course actually has 3 components. So the first part of the course teaches you the data science aspects in finance, teaching in deep all aspects related to data engineering, big data, data visualization using Power BI type and Python, all in context of finance. That's the first 3 months of the course. Then the next part, we have like modules on machine learning techniques in finance. So understanding the machine learning theories in deep, starting from the absolute basics of supervised learning, unsupervised learning, deep learning, neural networks, NLPs, and all, particularly their applications in context of finance. And the third part is where actually you get to super specialize. There are 4 electives, and you can choose to do any one elective in the course. There are electives like data science for finance, AI for derivatives, AI for risk management, AI for trading, and generative AI in finance. You can select any one elective to super specialize. Of course, you can do multiple electives as well if you wish to, because this course is actually in a modular fashion. So, people can do only part of the course as well. So if somebody wants to learn only the data science part, they can do a course of only the first 3 months of the module, and they can get a certificate in data science for finance. If they want to only do the machine learning for finance part, they can directly join the machine learning for finance module, which would be of 4 months, and then they can do it as a separate certificate. And as I was mentioning about the specialization modules, so these are the 4 specialization modules which are part of the AI for Finance course. However, if somebody wants to take multiple modules as a part of the AI for Finance course, they can do more than one as well, of course, with additional fees to be paid for additional module, and this can be all done as independent certificate programs as well. But if somebody directly wants to join this courses as an independent program, say for example somebody wants to do AI for trading, or AI for risk management, or generative AI for finance directly, then again we would assume that they have a strong background in data science and machine learning in general. Then only they can directly join this application modules, and then you can do it as separate certificates. If somebody does not have the background, then we would suggest and request them to go through the entire course, right? So these are like the courses which one can utilize to learn and then make a very deep career in the field of data science, machine learning applications in finance. And of course, there are courses in the core financial engineering and quantitative finance as well. So those who want to become quant or work in the risk analytics industry, there are a couple of courses you can look at. Certificate program in financial engineering, which is like a 7 months weekend program, which deep dives into understanding the deep mathematics and mathematical modeling in for derivative valuation, pricing, risk management, and all that. There's another course called Quantitative Finance and Risk Management, another very well-designed course, but relatively less mathematical compared to the FE. So here you also understand the practical valuation and pricing of different derivative instruments using the models that are used for each asset classes, understanding the models and implementing them in Python. Then both the courses, which is like deep theory plus implementations in Python. All our courses actually have like the model building and implementation as a part of the course. Our courses are known in the industry to teach both the theory plus the practical model building. And then in the quantitative finance and risk management, we also have more deeper coverage of the risk management areas compared to the FE. So both are courses in the same domain. You can choose either of them depending on your background and inclination, right? Then if somebody wants to specialize in algorithmic trading, so there is a very deep course of 8 months which teaches all aspects of algorithmic trading, building algos, the steps and processes, an entire setup, system building, and everything, including different kinds of strategies, right? So these are serious courses which somebody can utilize to make a career in this field of quant or financial engineering or machine learning or data science or related areas of finance in advanced analytics, right? And yeah, it has been a long journey of like more than 1.5 decades. Many participants and students have gone through our courses. Most of them have been working professionals, but they've utilized our courses to basically make a very good career in quants, and some of them were already working. They went much deeper and into much deeper profiles, right? So few examples, you can go through their experience that they have shared in the testimonial page in our website. It will help you in understanding how you can also use to basically build a career in this very fantastic field of financial engineering and quant finance, right? So there are different courses targeted at different areas, which I have briefed about, right? And now it's particularly about the AI/ML career track, right? So essentially, as I was mentioning, so we have very focused courses on machine learning and data science aspects of finance. So what are the potential career avenues that are available in the industry for aspirants of AI/ML program? The AI and the ML programs cater to building practitioner level skills to broadly cater to any and all AML and data science driven role families, with a few examples from the job market given below. So you can target roles for being data scientist, for being for financial and accounting decision systems. You can be targeting roles in machine learning, model designer, or financial forecasting and predictive models. You can target roles in forensic audit data scientist, as forensic audit data scientist, or you can be a fraud analytics machine learning expert. You can be in risk finance compliance machine learning data engineer. You can be a machine learning modeler for quantitative financial models, machine learning driven algorithmic trader, machine learning model validation expert, right? So these are few examples of the roles that you can target. And in terms of like our support system, so our support system starts as soon as you inquire with us for any of our course. I mean, it is not only about that the support system is after the course, but even when you inquire with us, we generally discuss with you in detail, understand your background, and then suggest the right course for you, the right path for you, right? It starts from absolutely when you start interacting, right? And once you start doing the course, then I mean, anyway, all the lectures are taught by leaders from the industry, and of course we have support system on career mentorship by industry experts. There's a dedicated placement support team. They tirelessly work with you once you complete the course in your resume building, LinkedIn, your profiling, then again your interview preparation and all that, and then they use our strong network of industry association to get your interview calls, right? So there's a strong support system on placements. If somebody is looking for a career in this field, they definitely can utilize all these services. Types of companies, yes, mostly would be like, again, hedge funds like another trading desks like Renasa Technology, Audis, or Citadel, Millennium Partners, etc. There would be, I mean, you can target the international investment banks and commercial banks like Goldman Sachs, Morgan Stanley, Deutsche Bank, JP Morgan, Citibank, Nomura, to name a few. You can target jobs in stock exchanges, NYSE, NSE, etc. I mean, of course, consulting firms, they are huge recruiters of people in quant analytics and this kind of advanced analytics areas in finance, EY, Deloitte, PwC, etc. Of course, IT companies, particularly the larger ones like MNC ones, Accenture, Cognizant, TCS. And then for people who are particularly doing data science, machine learning related course, another huge segment to target are the new age fintech organizations, right? So which have come up hugely. So there are a lot of areas to target if somebody is interested. I mean, I'm not going deep into this. So this is like a very short summary. I mean, practically anybody working in the quant and risk analytics domain has been an associate with us with some of the other capacity, but just to, this is just a very short summary of like some of the names that you might recognize, right? So all the international banks, big four consulting firms, stock exchanges, I mean, other banks and organizations, right? So, and yes, I mean, since the IIQF was formed as a body to promote the quant finance field in India, right? So we regularly work with even educational institutes as well to promote this field in India. Of course, quant is now like a lot more known field compared to where we started off, but maybe a little bit of the contribution has been ours as well, right? So we have been tirelessly promoting this quant areas, quant finance and financial engineering field in India. So, I mean, we generally conduct a lot of events and workshops and other things with the leading educational institutes. Again, a very small list of the institutes that we have worked in, IITs and other leading institutes. I mean, in September itself, again, we have like an event at IIQ, I mean, at IIM Ahmedabad for their Red Bricks Summit, which will be an inter-IIM meet, right? So this is something we regularly do to promote the field. Anybody getting interested in this kind of courses, or like, again, even if you don't want to do a course, you want any guidance, you want to discuss anything, I mean, you want anything further, we are happy to help. So you can contact us through our website iiqf.org. You can call us on this number. I mean, this is one of the numbers, 8976993622. The other numbers are there in the website also, or you can email us at info@iiqf.org. Right. So yes, I hope Sanjay, you utilize this period for the little quick breather.
Yes, yes, definitely. Yeah.
Yeah, I mean, we can't see you. Yes, we can see you.
I'm back with the fireworks now. Right.
So yes, there are a good number of questions which I would modulate for you, and then all right. So Professor Nirmala Devi, you have mentioned that to know you are joined this webinar to know more about risk management and risk assessment in financial models. Okay, so I mean, but if you have any specific questions now, after since we have gone through the the discussion, right? So please feel free to type in. We'll be happy to take up. So okay, so let's go to the question that is next, which is there. All right, so next question is from Riaz. Little different actually, but Sanjay, if you want, you can take it. He asks, like, again, it might not be exactly on topic, but Riaz has asked, can you explain how AI can help in trading in the equity markets? Would you like to take it?
Yeah, sure. So, Riaz, that's a very relevant question, and because AI has been on the front running side of trading, and specifically high frequency and low latency trading, right? And we have already seen that many of the traders have been replaced by the algorithms, and specifically in proprietary trading and high frequency trading, right? So AI leads to at various of these proprietary trading firms and high-end broker dealer firms, as well as hedge funds and all of those. AI leads to strategy discovery, right? Because it has this potential of doing data mining and data discovery to come out with different strategies. And since last decade and two has been markets, very volatile markets, so many volatility based strategies and very complex strategies like arbitrage based strategies are designed with the insights from the AI/ML models. And the other part is that AI/ML model naturally have this tendency to handle large volume of data, like what we call big data nowadays, right? So they can produce real time analytics, right? They can produce real time decisioning while taking a position, whether to short a particular whether to take a short or long position, whether to take some kind of a complex exotic strategy, some kind of a complex exotic strategy to exploit market anomalies, market irregularities, market mispricing across markets. Those kind of things are AI/ML is naturally good at, where many of the numerical Monte Carlo based or older way of doing things have been replaced by heavyweight neural networks and deep learning algorithms to do the task, right? and more so that the old regime of models, mathematical and statistical models, they need every time, suppose they are also equally good, but they need quite a lot of redevelopment and revalidation and re-benchmarking and re-backtesting. These AI ML models on the other side, many of these things they do themselves, all by themselves. They are automated way of taking decision. They're auto functional, right? So that's also one of the inherent advantage which they bring to the table, and that's why they are quite extensively used, and that is one of the low hanging fruit which has been very much exploited, uh, so in last 5 years, especially 5 to 7 years, by many trading firms to redesign the way they do trading in the markets, right? So that's where we have pretty much a long way to go, right, to completely see AI ML taking over entirely the trading world. But they have already had a significant footprint in the trading applications.
Absolutely.
Yeah.
Absolutely. So, Riaz, I think I hope that answers your question. I mean, please do feel free to type in any follow-up questions you have. Next is not a question actually, but again, maybe Ruchika actually, she is a research scholar from DTU, and she is working on XAI and user experience. So she says that I am looking forward to get some crucial insights about FATE in AI today. Many thanks. So Ruchika, I hope you got some insights, or like again, if you have any follow-up questions, you can put up, and we would be happy to take on that. Right. Let's go to the next question. Actually, so Anadi Gautam has asked, can you explain again surrogate model development? So
Okay.
can you take?
Yeah. So the surrogate model development is a way of a comforting way. Like there are many known models which are generally favored, considered more suitable and favorable for by various stakeholders who are looking for specifically the model explanations and model interpretability and model comprehensibility and model intuitiveness, like the decision tree, like your logistic regression, like rank order logistic regression, right? So these kind of models, if we build these models not for the main model, but as a tool to explain our complex model, intricate AI/ML model, then you would say why not to use these model instead, as we have been using so far for the main purpose. uh,
Right.
the answer to that would be that AI ML models are very good at some things which these models are not, like handling non-linearities, handling multicollinearities, handling high dimensionality in the data, handling noise in the data, right? Handling various kind of confluence of factors, handling different kind of data, not only traditional data but modern day data, like using the Twitter data to do the sentiment analysis, right? Which with the application of large language models, with the application of generative AI, we could also do a lot in those areas where data is there's a data uh, what you say scarcity, right? So where data is scarce, we could do synthetic data generation, right? So AI ML models naturally have very startling competitive advantage over the traditional statistical models. But yes, statistical models will still be favorite of many because they explain well, right? So why not to combine these two and bring up a surrogate approach? You build a statistical model for explainability of the main champion model, which is going to be the AIML model, right? That is the surrogate approach, right?
Yeah, absolutely. Right. I hope that you could understand now, Anadi. Going to the next question is from Pramod. So Pramod has asked, what are the typical requirements of regulator? Is there any minimum percentage of explanatory nature of models do they accept?
Mhm.
So that's the
Yeah,
question.
yeah, that's a good question, and regulators themselves are not pretty sure, right? I have to admit, and nowadays they are themselves going through a radical change, right? They are coming up with a different arm of themselves, a different outfit of themselves, which would be completely focusing on these kind of models which we know by regtech, right? The need for this arm is that how to regulate the fintech world and the fintech companies, and now they are very pervasive, right? They are pa- they, they by trading volume or by lending volume or by the kind of market footprints, they are no less they are not insignificant as they used to be, right? So to answer your question, what they are actually looking at, they have only expressed in principles, right? Not in a quantitative way, right? On a case to case basis, they give feedback on these models in a quantitative way. But uh, what they what my hunch is, when it comes to the model accuracy, they want at least 70 to 75% accuracy to be explained, right? So we accept the model at an AUC accuracy under curve, or maybe of 75%. That model should be 70 to 75% accurate. So they want from depending upon regulator to regulator who's more conservative and stringent, you can take a broader range between 60 to 75% is the something minimum explanation which they want from on for both the local effect and the global effect, especially the global effect, why the model has been designed through and how it is doing a better job than the traditional statistical model. And the second aspect is, every time, because this is still initial nascent years of AI/ML adoption, we have to still present them benchmarking results with respect to the statistical model, that our statistical model was performing like this, and this is our AI model which is performing well better ahead, far better than our statistical model, and this is the explanation with the statistical model. Yeah.
Yes, I hope that answers your question. I mean, any follow-up, please feel free to put up in the chat window. Lakshmi Narayan has only asked, like, again, it's a very short question, cost and question mark. So Lakshmi Narayan, sorry, we could not understand your question. So I mean, if you can elaborate your question, we would be happy to take it up. So please do mention, I mean, what you mean by that cost. Okay, so now going into question from Ashish. Ashish, his question is how explainable AI and interpretability can be used where we have multiple AI agents optimizing their decision in reinforcement learning. So that's the question.
Yeah, so that's a very good question, and rather maybe area of novel research itself, right? Area of novelty in itself. So in reinforcement learning, where you have for the audience, I'll tell you that maybe reinforcement learning is an online learning, right? It's an online form of learning where you have an agent who is learning a value or a policy, right? To maximize a policy or to follow to maximize and create some kind of a value. So the optimization is to how to increase the value, right? And how to learn the policy well, so that the model will make the least error, right? So in such cases, in reinforcement learning cases, there's something called maybe what if scenario approach which we could use. We could prompt the agent with different scenarios, and we could get the responses, right? What kind of online real time responses the agent is giving, and then we could explain if there's a consistency or persistency in those, and whether that particular the kind of decision agent is taking, right, can be explained through some kind of a uh, variables, or maybe what kind of specific focus areas the agent is focusing more upon, and which the agent is focusing less upon, and why where the agent is focusing more upon, right, why they are important for that particular policy or value function in question. Yeah.
Yeah, absolutely. So I hope that answers your question. Next question is from Karthik, and he has mentioned that are there any courses for finance professionals like chartered accountants who currently do not have background in data science, machine learning, but want to get started on this field. So let me briefly start by answering that question, and then actually, of course, you can add on. So Karthik, first thing is like, again, if you really want to understand data science and machine learning, right? So whatever background you come from, whether you are from a finance background, engineering background, mathematics background, or a science background, or any other background, you have to get comfortable with few things, right? I mean, one, you definitely need to get very comfortable with at least one programming language, particularly Python, which is the most used language programming tool in this industry, right? And second aspect is that if you talk about data science and machine learning, there are a lot of advanced statistics and good amount of mathematics will be used, right? So, I mean, yes, but said that, right, these are things you have to get comfortable with. Depending on, I mean, there definitely are courses which you can join, and I mean, if you can get yourself to be comfortable with this kind of things, there are courses which actually you can definitely join. I can definitely vouch for the fact that the course that we teach, we try to cover from as basics as possible. I mean, we give you a lot of resources to learn the basics of Python. In case you do not have a Python programming background, we do give resources to learn the basics of relevant areas of mathematics, statistics as well, right? In case you do not have those kind of backgrounds, right? So we do provide a lot of resources for those who do not have adequate background to make up for this kind of areas, right? However, the way we suggest is if somebody does not have a background, then whenever you plan to join any of these courses, we would request you to join maybe 3 months, 4 months before the classes starts, so that you can utilize our resources to brush up on the relevant areas of programming, mathematics, and statistics. So I'm sure there are other courses also where I mean people would be, or institutes will be providing resources for you to learn. Only one thing I can add on to it is like, see, basically this data science and machine learning are relatively sunshine industry where still a lot of development is happening, right? So, and I mean, going forward, the way these are getting entrenched into every field, every professional, including pure finance professional, ideally should understand some aspects of data science and machine learning, because this will be all pervasive actually, right? I mean, it is getting already, it's like used in most fields, including finance. It would only go more deeper and deeper. So it's always makes sense for all professionals, particularly those who look to work in the industry for the next 10, 15, 20 years, right? So essentially, or maybe more, right? To learn machine learning and data science as much as possible, because this is something which will become probably compulsory in every industry, including pure finance. That is like how the industry is moving. So Sanjay, anything you want to add?
No, I think just one point maybe, because I teach the subject and these courses, so I can comfort you there maybe, that even as of today and so far whatever batches we have completed, the CA and pure accounting background, strata of people are almost 20-25%, and right, and they take advantage of the primer modules which we cover, right, through live teaching, through interactive sessions, as well as the curated content we provide them, starting from really very basic, like your elementary level, as if you were in your high standard, secondary school level, right? We start the differential equation or integral calculus, differential calculus, or probability or statistics, or maybe other elements of all of that from there. And obviously, some of our other mentored who are very experts in uh, teaching the tooling and programming and coding part. They not only teach just Python, right? I just want to make that they also teach you the overarching uh, programming, right? So that if today Python and maybe tomorrow Python, but day after tomorrow if some other language, you would be easily be able to pick up those pieces together, right? How to do programming, right? So you will get to know those kind of things as well. So and that's very rigorous. We have a focus there because our purpose was not to make this course pretty exclusive to only quant finance and risk management and risk modeling and those people who already have background. but to make it as inclusive as possible, right? So
Yeah, absolutely. And just so that you don't get too much perturbed. So essentially, I mean, though a lot of mathematics statistics is like covered, so just think of it like again as understanding the overall concepts, right? I mean, nobody will tell you to solve any mathematical or statistical equations here. So this is like a more of an applied study. But yes, nonetheless, this concept has to be understood. And as Sanjay mentioned, I mean, we do a lot of hand holding and background building for people who come from non-mathematical or this kind of background, right? So yes, at the end of the day, we are teaching in context of finance, so it is natural for a lot of people to come from pure finance background. And so yes, I mean, in that context, we try to help as much as possible, and people generally get comfortable. So yeah, let's go to the next question. It's from Ruchika. So she has first of all mentioned that foremost, thank you for the insightful session. I have query. Thanks, Ruchika. It's great to know that you found the session insightful, and again, you have liked the session. So her question is, I have query regarding the waterfall plot and the other one as you depicted. Each variable contribution in terms of magnitude. Higher the magnitude, higher the significance of variable and its contribution in achieving the goal. This is what I could conclude as of now. Anything else, like any other descriptive analysis or explanatory analysis, these plots? Oh, just give a moment. It's a
mhm.
big question.
So yeah, so
So the question is not complete yet.
okay, no, sorry to
No,
preempt.
no,
Right.
so essentially some part of the question actually went down because of the big question. So just let me complete. So anything else, like any descriptive analysis or explanatory analysis this plot gives, any reasoning as this much can be done by multiple linear regression. Kindly correct if I am wrong. So what's the difference between these plots and MLR? Yeah, so that's the complete question.
Yeah, that's a natural question, and obviously, by just heck of looking at the output, you sometimes see it not very different from a linear regression, but it is a lot different, right? Uh, Linear regression, what it does, right? MLR, what it does, it keep all the other variables as constant and examine the effect one by one, right? Like
Right.
if I have 20 variables in my equation, right? MLR equation, I keep all the variables constant at a time and see the effect of one variable, right? This is not the same thing. The game theory is that or the decision theory on which it is based, the correlation or decision theory on which it is, or cooperative federation theory on which it is based, it is like everybody is playing their role. And we are examining the effects of all those 20 set of variables, how they are contributing towards the output at the same time, right? But we are doing simulations, we are changing that setting also in the next simulation and seeing, just to be comfortable, that a particular variable on which we are interested to notice the effect, that variable has the same effect across different setups, right? Like a team player who is playing an attacking game, right? When it is part of a particular team, like what if I team change the team and there are other attackers as well who are equally good? Does that variable still contribute to the same extent? So this is kind of the marginal average marginal effect, right, across all these different setups, right, is noticed, which is very different from how simply in a linear case or MLR case the effect is noticed. The second main difference is that generally the SHAP value analysis or lime is also able to explain the non-linear effects as well. That's the most prominent thing. The linear effects obviously to some extent could be explained by a linear MLR model as well as SHAP values, but what about non-linear effects, right? How, and specifically when these models are deployed on for handling complexities like non-linearities, obviously we want to know how much of which particular variable was the best predictor for the non-linearity, which could not be done by MLR, right? So period short MLR could not maybe go beyond what it is designed to do, right? And from there forth, right, if you want to build a model which do justice to the problem use case, the complexity of the problem use case, like the inherent non-linearities, then you need to employ some kind of a better explainability technique like SHAP explanations. Yep.
Yeah, I hope that answers your question. So the next set of questions is like from Professor Nirmala Devi. So since I asked her like anything specific, so I mean, first thing is the mentioned applications, particularly in stock market. So I believe that part, Professor Nirmala Devi, we have already taken up in one of the past questions. The next part of the question is something I would like to go directly to. So she mentions any specific software for managing the risk management in trading using AI. So do you know of any software which does risk management in trading using AI?
Mhm. So let me still mention few lines on the first part. Professor, like there are multiple time series forecasting techniques like ARIMA, Cerimax, Gauge arch models, right, which are now being replaced by this recurrent neural network, specifically the long short-term memory and the gated recurrent unit, and many of their adaptations, right? So the sequential learning, the problems of Markov chain decision process, and all of that is now heavily done through the RNN, recurrent neural network, as part of the deep learning algorithm. And that's where we do the price forecasting, return forecasting, loss forecasting, volatility forecasting, VAR forecasting, expected shortfall forecasting, all of that. So that is the first part, right, which is when it comes to the trading or the market risk, what kind of use cases are there which are prevalent and now being experimented and exploited. The second part is that whether there's a software which could manage the risk for these maybe mm, algorithms. I would say not really. It's a very bespoke and customized, capability you have to create to explain these models and to control their risk, because this is not one size fit all kind of a solution, because it literally depends upon what kind of algorithm you have, this complex machine learning algorithm you have, and what is its methodology, how what is its design, right, and what kind of data it has used, whether that data has GDPR related concerns, right, some privacy confidentiality related concerns, where whether that data has some ethical concerns, like making sure that the model doesn't do a discriminative decision, whether that data has a explainability concern in terms of the model traceability to the actual drivers of the model, right, what kind of thing concern is concerning for your stakeholders, that depends upon. And obviously this is a research area and very recent area, very nascent area. uh, no product company, to my limited knowledge, has developed any kind of a product which could be adopted for such an application. Yeah.
Yeah, absolutely. So essentially, these are things probably at this point of time and done at like more of a proprietary level. So maybe as you rightly said, no known publicly available products in this area as of now. Uh, yeah, so like with that, moving to the next question, which is from Mohammad Nias, and he has asked, can you explain algorithmic auditing in finance context? How can XAI help in
Mhm.
auditing? What are the things auditor look in ML models?
Okay.
Would you like to take
Mo-
that?
yep. Mohammed, again, very good question, right? And many of these auditors, like big four audit firms, and beyond that, like many others as well, Grant Thornton and others, right? What they are doing is, what their auditors are doing is, they are specifically interested in anomalies in financial reporting and accounting, and also anomalies in asset valuation. So I'll talk through the asset valuation use case, right? So when somebody is trying to audit the some kind of a various asset valuation and models, or various product control models on top of that, right? What they would be interested in is P&L attribution, right? That the P&L for that particular portfolio or product, right? How that is being attributed, right? So P&L attribution is one of the area where auditors, specifically the algorithmic auditors or model auditors, they focus on, specifically within the realm of asset valuation, right? And they specifically look at those areas where uh, these time series of P&L which has been generated by that particular portfolio model, right, sitting on top of the portfolio, right, whether that is matching with the empirical data, right? So whether that kind of or maybe creating a theoretical hypothetical portfolio, whether the same kind of P&L would be seen on that particular portfolio, right? So such reconciliatory exercise, and especially where AI/ML models are involved, their focus is more because AI/ML models are generally considered as very aggressive, very overfitting, and very overlearning. So they might be very sensitive to do some attribution which could lead to some errors, right? So that's why maybe that is the auditory way of looking at it. And specifically these firms, big four firms, and these audit and assurance, quality assurance or audit assurance firms, they are themselves developing certain models, right, to look into this and to figure out where maybe a model is not able to attribute. And the second part is the financial forecasting, right? And the balance sheet valuation, like the various items on the balance sheet, how they're fairly valued, the fair accounting, the fair valuation principles. And that is again one of the area where maybe there's a very heightened focus to develop some AIML capability, to maybe to see various reasons why, at what point a particular misvaluation or maybe a particular unfair valuation happened, right? And what transaction trades could be related to that particular fair value of a particular portfolio or a particular asset sitting on the balance sheet. Yeah.
Right. Okay. So now we are already 15 minutes past time. So we will take up the next few questions very quickly, maybe next 4 or 5 questions in the next 15 minutes before we wrap up the session. Right. Okay. So there's a follow-up question from Mohammed. So he has asked, do we have auditing in Indian companies, AMCs set up in India? What is the level of current auditing in India? Maybe I'll start answering that question, and then actually you can add on if I miss anything, right? So first of all, Mohammed, we have a very strong body, ICAI, so through which actually, like in chartered accountants, they take the exam and pass out, right? So essentially that has been set up by a government act, right? So auditing is very, very strong in India, actually. In fact, both for domestic this audit firms as well as the MNC firms, all of them have their offices in India. So there are like a lot of organizations which are specialized in auditing, and like again, auditing is like a strong regulatory requirement for all companies. So yeah, it's a very, very well established field, and I mean, auditing is definitely considered more world standard actually, right? So yes, it is there. Anything you want to add, Sanjay?
Yeah, so if Mohammed, your question is specifically to model auditing, just for you to know that the model validation
Um,
nowadays,
Pardon,
which is
just to interrupt. So no, this is not about model auditing. He has talked about current auditing. So general
okay,
auditing actually in
okay.
context.
Then
This was
then then
not
maybe
about.
whatever you have said is relevant. Yeah.
Yes. It was very specific to auditing as far as the question I mean, comes out to be. Mohammed, if I'm wrong, then again you can correct me by again sending another question. But again, as far as I understand, it was on like the general auditing. Okay, so then again, like going to the next question, which is from Kaustav. Kaustav has asked, is there any age limit in AIML course or placement? Sanjay, for you.
Uh, no, age I don't think is a barrier, right? Right. Mindset is a barrier, right? Age is not specifically. And because the point is this, that somebody only look at the darker side of this, that it is going to take away jobs. No, it's not going to take away jobs, it's going to replace the jobs, right? And those jobs which are newly created are far more rewarding than the jobs many of us are currently part of, right? It's about how you place yourself, right? Age is not the limit. And as Nitish also pointed out, that with the evolution of fintech industry and many other avenues where these models are heavily used, heavily deployed, right? uh, there's no dearth of opportunity. And the other part is those, obviously, we have a focus on finance because it is one of the most complex domain of all. And teaching the data science, machine learning, AI from the financial standpoint, from the standpoint of financial use cases. But if somebody nail AI, ML, or data science, they are agnostic of industries. They could work in any industry, right? It's not just confined to finance, right? It is a broader cross industry, cross sector, right, kind of a wave. You could get into any industry, right? So age and those kind of physical things, right, doesn't really matter. It's all about skills. It's all about, there's already huge demand for such kind of a roles.
Yeah, so to add to it, actually, like cost of this is one of the very rare field where actually, if you build your proper skill set, you can actually move from other industry as well. Being an industry which is still evolving, so there is like still a lot of dearth of actual trained manpower. So if you prepare and train yourself well, I mean, then definitely you can move. Yeah, said that, when you say age is a limit, if somebody is like up in 50 years old and then trying to change, there can be some other perspective which the companies can actually feel, to be honest. But again, in general, age, as Sanjay rightly pointed out, is not like a factor, right? Also, it depends and varies between companies to companies. If you're talking about like an international bank or like maybe big four consulting firms, sometimes like again, they might have reservation in hiring somebody in a junior position if you are like having already 20 years experience in a different field. But I mean, there are a lot of other organizations like new age fintech organizations, they don't have this kind of hang-ups, right? So I mean, anybody knowledgeable, they generally welcome. So I mean, it's not like a one standard question, I mean, answer, but in general, this is a field which is a lot more open to people of any age, of any kind of background, as long as you build the skill set, right? Okay, so next question is from Ruchika, another big one actually. So another question I would like to ask is, the second slide, Sanjay sir mentioned the trade-off between explainability and accuracy. So this explainability seems to be more for stakeholders, regulators and developers, not for end users. Do you think providing in-depth explanation will work in favor of user, which also includes the naive users, or it will be cumbersome, it more impact the reception, adoption, and retention of AI applications negatively?
That's a good question. And maybe putting the horse mouth there, right? The regulator view is that no banks are not charitable organization, and they are money making machines, and they are profiteering outfits, right? They would never on their own try to explain their decisions to counterparty or customers, right? Obviously, and that's what we all know, right? We have seen through various crises how it happened, right? It's a regulatory maybe with the adaptation of these AI/ML models, the regulators see a possibility of explaining the output to the customers as well, and making sure that the nothing discriminatory happen. Because previously, many of our statistical models and mathematical models which used to be there, right, there used to be some person who used to sit and maybe uh, take a final call. But now with the front to back integration and many of these automated way of taking decisions, like peer to peer lending nowadays, I don't think there's anybody involved at a portfolio level. Some portfolio head would be looking at the overall portfolio, what kind of maybe lending decision has been taken. But on a case to case basis, nobody really, it's just algorithm which takes the decision now, or which assign the application score. So there's a lot of focus from the regulator as well, that if they want to give a green signal or green light to these kind of models, then the explainability to the customer or to the consumer counterparty should be there, right? And bank will do on their part as well, because eventually it will lead to some kind of a legal battle where many customers will file legal suit, and they don't want to sit on a ticking time bomb, right? They would try to proactively uh, do something within the model which could explain it to the customer as well, why such decision is taken, whether it's about the limits, it's about the pricing, it's about maybe kind of decision making around their credits, everything about around them, right? It's about how we are maintaining their confidentiality and privacy while asking for more data from them, because our model eventually needs more data, right, to understand them and to offer them better price or offer them better avenues to trade with us, right?
Yeah, absolutely. Okay, so there's a follow-up question from Pramod. He has earlier asked, so for accuracy is again dependent on data size, isn't it? So are there requirements of test oblique sample data sets?
Look, some of your statistical way of doing it, like law of large numbers and central limit theorem, and how you ascertain the what is the sample size which will make you uh, you know achieve that particular those particular results, like the sample mean, convergence to the population mean, will still hold, right? That's why we teach statistics first before starting with data science, machine learning, or AI topics, right? So that will still hold, right? The statistics will not go away. The application of statistics definitely has changed, right? But the statistics, core statistics for AI, ML, and data science is still the same. Yeah.
Correct. Yeah, absolutely. I hope that answers your question. Next question is from Haridos. Haridos has asked, I work on regulatory risk area like Basel 3 for reporting, especially I see for the regulatory data, explainability, interpretability, audit, able are key cornerstone. How do you see the role of AI/ML models in this area and opportunities around the same?
Like many Pramod, yes, yeah,
Yeah,
I think
Haridos.
Haridos, right? Haridos, like if you are into a reporting or controlling area, financial reporting or regulatory reporting or controlling area, it is much more important nowadays. Regulator is not asking the reports, frankly speaking. There's a new thing where regulator has already developed capability, like specifically with Prudential Regulatory Authority, UK Regulatory Authority, where they will ask you to give you their give you the they will ask bank to expose their API to them, so that they can pull any kind of reports, any kind of data at any point in time without asking and waiting for them, right? So you will expose your API to them, entire API to them. There would be a regulatory API layer which you will expose to your regtech or maybe a regulatory body, right? And they could pull any report. It would be just a drag and drop and pulling data from that. They could do it themselves. All you need is to tell them the filters, which will already be defined in the user manual, which you will give it to them with the API. Now the other thing is what they expect from you. Now reporting roles are gone. If that were to happen in next few years, reporting roles, controlling roles are gone. What would be then maybe the how this role can go to the next level? The move and variance explain, right, is one thing which regulator could not do, right? So you have to do a lot of move and variance explainability, right? And that explainability requires you to maybe process through a large amount of data, like not only billions of trades, to explain whether that move which you saw in a particular trade, right, is really responsible for the move in the portfolio, right? So those kind of things. And obviously you require all those AI/ML techniques there, because you're talking about millions and billions of data, right? And uh, across the organization, which is scattered all over the place, sitting in silos, you definitely need some kind of AI/ML capability to detect the pattern and to understand it before explaining to the regulators, why your portfolio numbers have changed or why your RWA numbers have changed, right?
Absolutely. I hope that answers your question. Now, like again, the next few questions we'll take very, very quickly, right? Maybe like two, three quick questions, and then we'll wrap up. It's already half an hour, almost half an hour past the time. So the next question is from Himanshu. So first thing is he said, "Hello, sir. This is great initiative. Big thank you. Thanks, Himanshu. Great to know that you like the session. Found it useful. The question is how the explainable AI is helpful or implement in corporate finance. How the model can be built in area of corporate finance with some examples. Would you like to take that question?"
Yeah. So in corporate finance, you deal with a lot of how to say, maybe a lot of these dealing with large counterparties where you give all kind of capex or opex kind of funding or limits to them or loans to them, right? So in corporate finance, what is now more important is that nowadays the bank is moving from normal corporate funding or corporate financing to a new wholesale funding, or what we call the wholesale credit risk, which is the corporate finance, to a new way of doing it, that is the carbon based funding, right? So even regulators are forcing banks to give more loans to those firms which are reducing their carbon footprints, and to discourage the funding in to those firms or those industries, those sectors where there's a lot of carbon emission or carbon dependency, right? So in that sense, it opens a Pandora box literally for corporate finance, because many of these corporates, big stalwart corporates, are not going to get funding because they are still sticky with their emission norms, and they are not moving ahead. And for banks, it's an important question that how to use the carbon footprint data, right, coming from the industry sector, region, sub-region level, and bake that into their lending decision, right? So their rating should have some variables which will be indicative of climate and sustainability risk of the firm, and then maybe that should penalize those very firms, even if they are doing very good financially. That would penalize those firms and notch down their rating, deteriorate their rating, who are not following climate and sustainability goals. Yeah. So that is one area where I see huge possibility of AI ML making its footprints and leading the way. Yeah.
Yeah, absolutely. So I hope that answers your question. I mean, that's actually a question which a lot of corporate finance professionals probably have. So thanks for that. So next question is from Nirmala Devi. Okay, hi sir, need guidance for selecting the course and career in AI and finance. Would be very happy to discuss on this one-on-one. I mean, we would definitely connect with you and guide you on both how the career trajectory, as well as like if you wish the course to be done, right? So not elaborating here for the sake of other participants and also for the sake of time, but we would definitely discuss one-on-one. Next question is from Bhusan, and he mentions any recommendation about AI bots for crypto trading, DEFI liquidity pools at all. Thanks beforehand.
Can you repeat the question, Nitish? Sorry.
Yeah, sure. So Bhusan has asked any recommendation about AI bots for crypto trading, DEFI hyphen liquidity pools at all. That's a question.
Yeah, so AI bots are now maybe recommendation means whether you like to know something, or maybe I could still say few things and then maybe let us know if that answers your questions, right? So for developing AI bots, obviously maybe for different strategies, you need to be a quantitative trading expert, right? And maybe these bots generally are part of now integrated trading applications, which give recommendations on different kind of patterns and different kind of maybe uh, uh, anomalies in data, or as well as some kind of new discovery from the data, which could lead you into doing trading in a different way, right? So but maybe on specifics like maybe liquidity pools and all, right, it would be a lengthy discussion where we would need to maybe go into that particular use case. But in general, yes, that is very much prevalent. And now a lot of front and trading firms have already started building these AI chatbots into that particular trading applications. Yeah.
Absolutely. Okay, going quickly to the next question from Dr. Kalavati Ramesh, and she has asked, how can AI be useful in education? Let me briefly start with that, and then Sanjay, you can add that at there. So first of all, when you talk about general education, even without going into education specifically in the field of data science or machine learning, if you talk about effectively using AI and this kind of data science in effectively providing more better education, right? So particularly when you have this learning management systems and all, where you can track the progress of the learner and all that, right? So essentially there are a lot of work that is happening, including ourselves as a part of like our AI initiative in our improving our overall experience and overall effectiveness of teaching. We also do, and this is something which actually a lot of research and a lot of applications are currently happening, right? Where you actually progress the journey of the learner through AI-based and data science-based models, and then accordingly suggest them the pace of their work. The kind of questions. So a lot of things actually. So AI can be used very effectively. This is just a very brief thing actually, the way I mentioned. There are a lot of areas where AI can be used to implement education, even in a more powerful and effective way. And other than that, of course, when you talk about like in education in the subjects of data science, AI, and ML itself is like a huge area where every big small institute is focusing to conduct a lot of courses. So yeah, there are the huge applications of AI in education. Sanjay, anything you want to add?
No, that's all. The low hanging fruit would still be, which is currently extensively done as the content management, knowledge management, right? Where a lot of topical content has been there's a prompt engineering. There are some large language models which are applied to organize the content. And to suppose for your teaching purposes you require case studies, right? How and AI application could help you generate synthetic data or create case studies, or maybe curate the content specifically for your audience to have the highest impact factor on them, right? So that is one kind of area which a lot of knowledge content providers are focusing on, how to curate content for specific topics, right? And rather than going through the textbooks, or maybe a lot of which in today's age people have very less patience, right, to right. So now that's how to curate content for specific topical interest, right? That is also one of the areas of knowledge management which has been where AI and ML has been very predominantly applied. Yeah.
Absolutely. Okay, so quickly, next set of follow-up questions from Haridos, and then we will wrap up the session. So, a couple of questions. First of all, a follow-up. If yes, do you know what are the type of AI, ML, DL models or any software used for regulatory risk reporting purpose? Key metrics derived EAD, LGD, PGD, and RWA.
Like for RWA optimization, right? We have ourselves have used the support vector machine, right? Because the RWA formula is a pretty non-linear formula, right? And we wanted to see maybe what would be the sensitivity of RWA for conducting the sensitivity of RWA. Support vector machine is used. When it comes to DL models, right? Deep learning models, yes, as I told, for time series analysis and for many use cases, RNN is heavily used nowadays. In that is replacing the time series or sequential learning task which we used to do earlier. And the other one I would like to say for PDLGD modeling, right? For your interest specifically, random forest and ADA boost and XG boost. these three algorithms are heavily used.
Yeah, absolutely. All right. So I hope that answers your question, Haridas. So I mean, I think with that we will conclude the session for the day. I mean, it has been, of course, we have extended the time, but I mean, there were so many wonderful questions, and like again, thanks Sanjay once again first for like a wonderful session and like patiently answering all the questions. I hope the participants, you all had a good learning experience. I mean, it was the session was informative. Thank you everyone for joining in. It was great having you. And as you all know, so we regularly conduct this webinars on various important topics in finance engineering, quant finance, algorithmic trading, machine learning, artificial intelligence, data science applications in finance and related areas, right? So keep track of our various channels, website, social media pages, and of course, those who have been part of our webinars, they will be receiving the emails and intimations as well for the next set of webinars. So see you again all in the next webinar. I mean, thank you so much for joining. Thank you.
Thanks a lot. Thanks everyone.
Thank you.